All right, hello everyone, and welcome. One second. So I want to talk a little bit about Web3 today, specifically talking about smart contracts. So is anyone here familiar with this concept at all? Knows what a smart contract is? Totally new?
I'm only hearing about that every now and so often, but didn't really dive deep into it.
All right, let's dive deep. Okay, so what is a smart contract? So for now, I'm going to talk about Ethereum because it's the most popular blockchain for developing smart contracts on. So Ethereum is a virtual machine. It's a distributed state machine. It's a worldwide virtual computer. It's a stack machine, which doesn't really matter for our purposes. But you can basically upload programs to this VM and you can run them. You can, or more precisely, you can have everyone who participates in Ethereum run it. And you can upload these programs, they can call each other, they can expose like export functions, and they can maintain some state as well, both internal and externally visible state. And these are generally written for Ethereum in a language called Solidity, which we'll take a look at. So why is this interesting? Who cares? Well, this is actually a really cool thing that we have this worldwide VM. So it lets us establish a substrate for computing for the whole world. So where we can put state, it's kind of like a good append only log that we can use to store, records of tokens, of NFTs, of governance decisions, of votes, of domain names, of anything you want to represent. If you can do it in digital form, you can represent it in a smart contract. And then there are some ways to tie these contracts to things in the real world called oracles, but probably will not get into that too deep today. The possibilities for smart contracts, we're just getting started. There's a lot of things that will be built that nobody's thought of yet. That'll be maybe really obvious in retrospect. Who knows? Maybe not. But it's a mechanism for building a state that we all agree on and a computer that we all agree on. So the nuts and bolts of actually running these smart contracts is you actually pay people miners to process your transactions, and your transaction will be either deploying a contract or maybe calling some function in a contract. And these functions can be read-only, which are free to execute, or they can write to the blockchain, in which case you have to pay some money. And this money is called gas. So the gas is measured in Ethereum tokens, and you pay these miners some piece of that Ethereum to process your transaction, to run your program and write something to the blockchain. So gas is usually measured in gwei, or gwei, I don't know how you say that. It's a denomination of Ethereum. It's a very small fraction. And the gas price tells you how much you can expect to pay per unit of gas. So if you want to run some smart contract, you want to deploy, you want to call a function, you can actually go check the current gas price and see how much it's going to cost. Now, you don't really know ahead of time, if you're just a normal user, how much gas it's going to cost to call some function, but it'll tell you, your wallet will let you know how much you're going to pay in gas. Now, gas fees can be pretty expensive right now. There's a lot of demand and not a lot of transaction kind of throughput in Ethereum. So doing some kind of simple operation like a simple function call can cost $20, $30, $40, $50. Deploying a smart contract can cost in the thousands of dollars. This should get cheaper. Ethereum 2, which is perpetually around the corner, supposed to make gas prices much, much cheaper. We'll see. And there's alternatives besides Ethereum as well for writing smart contracts. And so what is a contract? Let's take a look at some of the most popular types. So the one that most of you are probably familiar with is a token. So a token it doesn't exist. There is no token. There is no like counter of tokens anywhere in Ethereum. All those records are internal to the contracts. The contracts that manage tokens conform to an interface. And so the kind of original interface is ERC20. And I think it stands for Ethereum Request for Comments. It's a implementation of an EIP, which is an Ethereum improvement proposal, like a pip in Python, I think, or something like that. So these improvement proposals have numbers. The one that defines the tokens that we can exchange that are fungible, we call ERC20. And then there's another type of interface which defines non-fungible tokens, where each token actually has a unique ID. So if you have an Ethereum token or a Mish token, each token is exactly the same as another. There's no difference between each token. They're fungible. But with an NFT, each token has a unique ID, which can have some metadata, whatever you want to store along with it. It can be a piece of artwork, it can be a ticket to a concert, whatever. And then there's a new standard called ERC 1155, and this kind of combines both of them into one. So you can have one contract that gives out tokens and keeps track of NFTs. And I think the kind of initial use for this is going to be video games, where you have some in-game currency and you have some sort of items that you collect that are distinct. Each item is distinct, and so that would be an NFT and a token. And I think the idea is to kind of make these portable, perhaps between games. We'll see. But these can be used for anything. They can be shares of a company. They can be tokens for governance, for maybe buying more votes, or anything that you can possibly imagine you can represent this way digitally. So this contract has a set of functions and some like public global variables, let's say, and you can interact with a contract. Once you deploy the contract to the blockchain, people can call these functions like balance of or transfer, and that's how the tokens move around. So the ERC20 interface, we'll take a little bit more of a look into this and deploy our own token, show you what that looks like. But the interface basically defines a name, a symbol. So that's like the 3 or 4 or 5 letter symbol you associate with a token, like ETH. The name would be Ethereum, and then decimals. And that's basically how many decimal points you have in your currency, in your token. Because there aren't really fractional numbers in Ethereum and Solidity for the most part, we just move around UINT 256s for the most part for amounts. It's not a great design. You can have negative numbers of tokens, which is usually a security vulnerability. There's some problems with it, but this is how it works. The standard these days for decimals is 18. And then you have the total supply. And I think there's a few other pieces to the interface, but the total supply is the number of tokens in existence. And then you can ask anytime, how much does this person hold of the total supply? And ERC 1155, I don't know too much about it, but it basically is ERC20 plus ERC 721. I think it'll be more popular soon, we'll see. Now, I want to mention that Ethereum is not the only option here for writing smart contracts. There are other blockchains, and there are also other projects that are on top of Ethereum or other blockchains. And these are all different ways of writing smart contracts. Some can be written in Rust, in C, in Haskell for Cardano. WebAssembly is another option. Some of these are much faster. I mean, the reason to not use Ethereum is 1, the gas fees, and 2, it's pretty slow. So if you make another blockchain, you usually do it with the intent of fixing these problems. And sometimes you trade off things, like maybe you trade off some of the decentralization. Like if you have a centralized layer that collects and executes lots of contracts and transactions, it can be super, super fast, but it's not so decentralized. But usually what these do is if it's on top of Ethereum, they'll write periodically a sort of checkpoint transaction to the blockchain. So it uses Ethereum as kind of a store of information that everyone can see, and then maybe some sort of processing happens above Ethereum, and then it's just the state gets written back, or it just happens on a completely separate blockchain that may use different ways of calculating and assigning artificial scarcity. So Ethereum and Bitcoin do it with mining, with trying to create lots of hashes. Other ones use proof of stake. Ethereum 2 will use proof of stake. Some use other schemes, proof of time and whatnot. One other thing that I just want to point out is zero knowledge proofs, ZKP or ZK snarks. These are mathematical protocols that allow you to prove things without necessarily sharing all the information. And I recommend reading more about these things. I think they have a lot of interesting applications. Mostly it's adding privacy to blockchain, because right now every single thing you do on the blockchain is public for everyone to see forever. With zero knowledge proofs, you can prove that maybe you transferred some money to someone else, or you sent some message, or whatever action you want to take. But not everyone can see who the sender and recipient were or what you actually sent, but you can still prove something about the transaction. And one really exciting one is Mina, and the whole blockchain fits in about 22 kilobytes, as opposed to Ethereum or other blockchains, which are hundreds of gigabytes and always getting bigger. You can basically have, right now, if you want to interact with Ethereum directly, you need to run one of these nodes. It needs to have a lot of computing power and a lot of storage. But with something like Mina, you can actually prove that the whole blockchain is consistent, but you don't have to store the whole history. So I just wanted to point those out as things that are very promising. Polkadot, Solana, Cardano, all these things. Binance, I don't really trust, but I don't really know anything about these things yet. So that's something to learn about. Okay, I want to do a little demo of creating an ERC20 token and show you how this actually works. Before we do that, any burning questions right now on any of what I just said? Nope. All right.
Oh, sorry, I do. I sent it in the
Before-
chat. So is Solidity like only for Ethereum blockchain?
I think yes. Now, Solidity, it's one of the first, maybe the first language for smart contracts, and it has some imperfections. Like I said about, having signed integers for balance, just signed integers that are used for money without actually having a built-in money type. So some of these other blockchains, when they create a new blockchain, I don't think they want to use Solidity. I don't know if you can, to be honest. I don't know much about the other options, but I think the part of the features is that you don't have to write Solidity. That's why you would use something else. That's why maybe you'd use Rust or C or WebAssembly, something that compiles to WebAssembly, obviously.
All right, thanks.
But I don't know if Solidity is used with any other blockchains, not to my knowledge. Okay, so this is called Remix. It's a web-based IDE for Solidity. It's not the only IDE, but it's kind of a easy and popular one. That's pretty standard. So I'm going to go ahead and create a new coin called JetCoin. And I'm going to delete some of the sample stuff that comes with it. Go away. We don't need this. And we're going to create a new contract here. So we'll call it jetcoin.sol. Why can't I just delete this? Okay. So you don't usually need to write a smart contract from scratch. What we're going to do is take somebody else's verified implementation. There's a lot of things that you can get wrong. And sometimes these are used for important things. So it's good to, take a look at somebody who's, knows what they're doing, or in this case, an organization called Open Zeppelin. So they publish a set of contracts, and you can see here they have all sorts, but we'll go with the very simplest tokens. You can see they have examples for ERC-721, NFTs, 1155, which we were talking about, and ERC-20, which is the token standard. And if we're curious, we can go read all about the ERC-20 standard here. As we saw before, we can see exactly what it consists of. If you want to write your own token contract from scratch, all you need to do is implement this interface and you're good. But we don't need to build it from scratch. What we're going to do is we're going to make use of Open Zeppelin's version here. And we can read through the implementation if we want. It's very simple. So for example, if you want to keep track of how many of your tokens somebody has, there's a map here, a dictionary. And it has a map of, sorry, that's balances, I mean. It's a map of address to a UN 256. So everyone on Ethereum has an address. That's your wallet. That's your public key, basically. So this is a mapping of someone's public key to the amount of tokens they have. Now, this is just an internal data structure. This isn't visible to the world, but this is exactly how you can keep track of how many tokens someone has. It's just a simple dictionary. There's nothing more to it. So if you want to say transfer money, let me find a simple example here. So if you want to transfer money, essentially it's just, we want to check to make sure that they have enough money to transfer it. And then we add the amount to the recipient and we remove the amount that you're sending from the sender. That's really it. Like the other stuff is just kind of like a hook and emitting an event. But that's all there is to it, really. We're just subtracting the amount from one person and adding it to another person's balance in our dictionary. All of these all of these executions happen inside of a transaction. So it is to some degree atomic. And then the other thing to be aware of, I would say, is mint. And mint basically creates new tokens from nowhere. So it increases the total supply and you mint for some address. So you give them the amount you just added. That's it. And so using basically these two things, you can keep track of how many tokens are in existence and how many tokens each person has. The rest is just kind of details that aren't even really necessary to understand or use ever, I would say. The allowance is just to let other people spend for you. Burn is to destroy some number. That's it. Okay, so how do we use this? Well, we can import this file and we can, I think, more or less import it like we would in, let's say, TypeScript or JavaScript. Now, one second. Let me just grab my example here that I put together. We can go through it bit by bit. So first we say what version of the language we're using. Just copy this to Jetcoin and we'll go through here. So we can say what version of Solidity of the language. And then we're going to import two things from OpenZeppelin. So this is actually downloaded from NPM. If we look here, we can see, yeah, there it is. These are the files that are being included from OpenZeppelin from NPM, basically. So one is ownable, which keeps track of who owns the contract that you deploy. And that lets you do things like this. So you can say, this function can only be called by the person who deployed the contract. And we're going to inherit from ERC20, which is what we were just looking at there. So the ERC20 constructor takes, I think, 3 arguments. First one is the name, the second one is the symbol, and the third is the number of decimals, which defaults to 18, if I'm not mistaken. I guess it doesn't actually let you specify the number of decimals anymore. Yeah, now you have to just overload it if you want to. That's fine. We're not going to. We'll use the standard. And then in our constructor, we can do something that's executed when the contract is deployed. So one thing you might want to do is give yourself all the tokens. You don't have to. You can have new tokens generated in response to other events or things happening. But you can also, if you want to make your own coin, you can just give yourself all the tokens in existence, and then you can decide what to do with them. So here we call mint, and message sender is the person who's calling your function or deploying the contract in this case. And you can specify a number. So this number is 1,000 multiplied by 10 to the 18th, which is the ether suffix here. So if you want to do smaller units, you can say 1,000 wei, I think is the term for it, or 1,000 gwei, which is a slightly larger denomination that's used for gas usually. But because we want to take the decimals into account, we don't really want to mint 1,000 because remember, we're not dealing with floating point numbers here, just integers. So we want 1,000, with the correct number of decimals following it. So this is 1,000 and then a lot of zeros, 18, I think. And then we have, I just made a little function here called give me more, and it's a public function, so anyone can call it, except only the owner can call it, otherwise it'll yell at them. And it just says, give me 1 more ether worth of tokens. And then I like to make this little helper function called my balance. Now, and this returns how many tokens the caller has. And we'll note that this has a few modifiers. It has view, which it means that it's read-only, so it doesn't cost anything to call. If your function doesn't even look at your state, you can instead do pure. And I think that in this case, that won't work because I'm looking at our state, which is, yeah, it doesn't like that. I think the error was something else, but whatever. And it returns a number. Okay, so how do we deploy this and use it? So using Remix here, we can go compile it with the right version. And we can optimize it if we want. I don't know too much about that, so I'm not going to talk about it. And then we select what contract we want. So JetCoin is the one we want. And compile it, it'll auto-compile. Anyway, and then we can try running it and deploying it. We can run it locally if we want, but it's more fun to actually deploy it to a real blockchain. So let's deploy it to a blockchain network called ROPSTIM. So what is ROPSTIM? So if you use any sort of wallet or look at any sort of Ethereum transactions, there's actually a few networks. There's the main net, which is usually what people talk about, but there's a number of test networks as well that you can choose to be on. So you can select inside your wallet which network to join. So I'm on ROPSTIM, it's just one of several. And you can see I have 1.5 ETH on here. This is fake ETH. Nobody who knows anything about nobody who understands anything will accept this as real Ethereum. It's all fake. If you want more fake Ethereum, you can go to what's called a faucet for each of the different test networks. So if you want, you can put in your wallet address here and you'll get some free Ethereum. But again, it's only on this different blockchain, on the test Ethereum blockchain network. So that's how I got some Ethereum here. If I want, I can just ask for more. Doesn't really matter. I have enough. Yeah. Okay, so what I can do, let me just disconnect this so you can see the process. So I'm going to disconnect. So if you have a wallet in your browser, you can go ahead and connect up to a web page. So there's a number of JavaScript wrappers for this. They usually use I wouldn't call it a standard, but a kind of interface called Web3. And that lets you connect your wallet, and it can be a browser extension. It can be a physical wallet. There's a number of different wallets out there. It'll connect basically through a protocol, your wallet to the browser. And then inside the browser, you can call contracts. You can do whatever you want on that network. So if I connect this guy, then now this is my account. So this is my public key here. And basically, if I want to do some action using this application on the web, it won't have direct access to my private key, but it'll ask me if I want to sign a transaction or deploy a contract or call a function, whatever I want to do. And so the provider is my wallet, and this guy is basically just calling some methods on that provider, if that makes sense. So I'm going to select the JetCoin contract here. I'm going to try to deploy it. So this is exactly the same as if I was on the real Ethereum mainnet. It's going to tell me that I need to perform my action here. So I am going to pay the gas fee to deploy this token. And we can see here that the gas fee is about $113. Now, this is in fake Ethereum, so this cost me nothing. But if we were on the real mainnet, then I would have to have this amount of Ethereum to pay the gas fees for all the miners to create the contract, because I want to upload this program to the worldwide VM. I need to pay for the privilege of doing it. I need to convince other people to let me use their computer to process all of this. So if I go ahead and confirm, let's see, did that work? Yeah, okay, it worked. So the contract is deployed here, and we can even look at the address of the deployment. There's a useful tool called Etherscan, where you can go look up any address. It can be a contract, a wallet, whatever. And if you go on Etherscan, you can change from mainnet to, say, ROPSTIM, and we can take a look on ROPSTIM at that contract. So here it is, 45 seconds to go. This is me. We created the contract. So now it actually exists on a blockchain somewhere. It's not the main one, but it works exactly the same. We can see this website created a little coin tracker for us called JetCoin. So we can see that there's 1,000 in existence. There's one person who owns them here, and it was created from nowhere. So this is the mint function. It just basically creates tokens out of thin air. And that's what we see here. Now, we have this contract is deployed. We can look at it. You can upload the source code so people can actually interact with it on Etherscan. I haven't done that, so we just see the raw bytecode here. And we can also interact with the contract. It's not a static thing. So these are the different functions here. So for example, I can say, what is my balance? And here it is. So this is 1,000, remember, with 18 decimals. I can get the name, I can get the owner, I can get the symbol. So that's where this JC, this JetCoin thing, that's where it's getting the information from in Etherscan. Because it conforms to the ERC20 interface, Etherscan knows how to interpret our contract. Again, this is all just interfaces. There's however you want to implement it is up to you, but as long as you conform to the interface, you'll show up as a real token on any wallet, on Etherscan, wherever. Now I can also call this give me more function, which mints a 1 ether worth to the owner, to me, only callable by the owner. So if I call, let's say, give me more, and then I call my balance, oops. So I need, because I'm writing to the blockchain, I need to pay some gas. So we can see right now I'm paying about 250 worth of gas to execute this. And then I should be able to go get my balance again, and maybe we'll wait a second. I don't know how long it takes or if it worked even. But it should increase my balance by 1 at some point. So that's how you can interact with a contract. You can do this all programmatically. So if you want to write, let's say, a web page that does all the stuff that this does, you can do that quite easily. So you know, I have 1,001 tokens. If we go look at Etherscan, for example, we should be able to see that. Okay, this is for the contract. Let's look at the token tracker rather. So we see that the total supply is now 1,001, and we can see here, this is where I minted, or I click give me more, give me one more. So that's what ERC20 looks like. ERC721 NFTs is much the same, except you happen to have a token ID associated with each individual token. That's it. That's main use of smart contracts today. But you know, what's really interesting is what these can represent. So it can represent, like I said, maybe shares in a company. So if you want to start a new company, it doesn't even have to be a company. It could be a nonprofit. It can be any kind of organization. If you want to create a new organization with people all around the world, and you want them maybe to help fund it, you can sell them tokens, and then you know, everybody gets to hold some number of tokens. And at any time, you know, to give some examples. So one organization, one DAO, decentralized autonomous organization, they're called, you know, you have to hold 75 of their tokens to be a full member of the group. And so you have to actually pay quite a bit of money to join this community. And they, you know, have a very lengthy application process to make sure you're a cool person or whatever. But everyone in the community, because they have a significant amount of money invested in these tokens, it's in their interest to grow the community. It's in their interest to participate. If the community gains more cachet, it becomes more prestigious, then the value of the tokens increases, and people will pay more to buy the tokens to join the group. And there's a fixed number of tokens. So there's a set number of people that can actually be members of this community. And if you don't want to be a member, you can sell your tokens to somebody who does. And so this supply and demand, in theory, you know, will reach an equilibrium at some point where the, you know, actual value of being a member of the community is correctly priced in. And if you're curious about how that exchange happens between tokens for money, the main way this is done right now is through Uniswap. And you can go on Uniswap and you can create a liquidity pool. And then you can swap, if there's a pool, you can swap tokens for anything you want. So there's everything, every sort of token is here. I don't know, should be able to swap for Solana, for example. Why can't I? I don't know, sorry. Not sure. Oh, it's probably because I'm on the test net, sorry. So if I switch to mainnet, we can see all the different tokens and you can see, what they're worth. So if you want to exchange, Ethereum for, I don't know, Solana, you can see what the price is. Yeah, I don't know. Is that Solana? I have no idea. But we can say if we want to trade 1 ETH, then how much Solana can we get? It'll figure that out, and somebody will commit their tokens. All right, this is not Solana, or I don't know what's wrong, sorry. But basically, this is the way that you can stake tokens. You can take like a chunk of jet coins, and you can say, okay, I'm willing to trade these jet coins for half an ETH each, or whatever you want the price to be. And then anyone can come and buy and sell within a certain kind of range that you define the prices. And so using a liquidity pool, you can provide liquidity for your token. You can make it redeemable into Ethereum, into US dollar coin, into whatever you want. And so you can create a value for these tokens. And then if you have some community where people join and have to have the tokens, then you create more value. And then the people in the community have an incentive to create more value for the community, because then their tokens become worth more. And it's a virtuous cycle in theory. And you can have these tokens, for example. Yeah, go ahead.
Sorry, Misha. And so from a functional point of view, it's like with what you show, you create kind of your own currency inside Ethereum blockchain. Is that correct?
Sure. Yeah. Mm-hmm.
Okay.
Yeah, it's your own currency, but it can represent anything you want, which is kind of the point. It's only limited by imagination. So there's a lot of people right now building governance layers on top of Ethereum. So for example, if you want, you can have each token represent a vote. And so people who buy more of the tokens have more votes in how the community is governed. And these votes they can happen on chain. They can have, there's websites, web applications built that let you propose things, people vote on them. And you could say that, people with more stake in the organization should get more votes. Or maybe you think that sucks, and maybe it should be one person, one vote. And you can just have people's vote by wallet rather than by number of tokens they have. However you want to do it. So I think what's cool about this is that it'll let people experiment with new forms of governance, with new forms of organizing themselves and creating new incentive structures. And they can do it without a whole lot of legal mumbo jumbo or lawyers involved. Can do it across borders. Can be anyone in the world can theoretically participate. And I think that's really exciting, because right now, if you want to do something like create a startup, usually you have to have investors, you have to have, be in this network. There's a lot of legal stuff you have to go through. People can't easily exchange their shares of the company for money or for shares of other companies. It's hard for companies to invest pieces of themselves into other companies. This all makes that very possible. And again, not just companies, but any kind of organization. So I think that's the real cool application. And just a matter of.
But for releasing it, you need like some money, right? Like if you wanted to release, for example, this coin in the real world, in the real, not in a fake network, like you need to have the money to be able to, I don't know how to say, create or, yeah, the amount of tokens that you need, right?
Yes and no. So there is the gas price to create the contract, and there is a gas price to interact with the contract. That is expensive on Ethereum. There are other chains where it's very cheap, and Ethereum will be cheaper when Ethereum 2 eventually becomes a reality. So there's that cost. Other than that, not really. Again, the liquidity pool is just one option. However you want to give these tokens value is up to you. So other than the gas costs, theoretically, you don't need any other costs. If you want them to represent in-game money, you can do that. If you want them to represent votes, if you want them to represent shares of fine art, whatever you want, it's up to you to define and create that economy.
Understood. Understood. And with the fake networks, you use the same address that you will have in the real network of Ethereum. Like your address is the same.
Yeah, you can create as many wallets as you want. You can create new, it's as simple as creating a new public-private key pair, basically. But by default, yes, it's the same address, whatever network you're on. So
Okay.
if I'm on Ethereum, it's the same address as on ROPSTIM, whatever.
I have a question. Like, let's say that you create a token for whatever. How can someone see the like what are the options with this token? For example, like how can someone from the outside be sure that it's safe and legit or whatever?
Good question. So the contract, so there are at a high level, there's organizations that audit contracts, like Open Zeppelin and like a few others. And there's a new project called Avalanche, which is trying to make safer smart contracts that I'm pretty excited about. But generally, your contract is, it's deployed, and you, as I showed, you can see the bytecode. Most people can't do much with that. So what you can do now, if you give me a sec, I'll show you. If we switch over to the mainnet here, so let me pull up one contract, Devs for Revolution. This is an ERC 721 contract, and it's for NFTs, but it works exactly the same way. We can see here all the people that are transferring these NFTs. And notice that there's one more column here. We have token ID. So this is where the NFT part comes in. Each token has a unique address. You can look at that particular token. You can see what it represents. And you can see the transfers, like where it came from. So here it was minted 35 days ago to this person, and then this person sent it to this person. Now, the contract, to answer your question, what you can do is once you've created a contract and deployed it, you can upload the source code of the contract. So you can interact with it here if you do that. So you can put in like a token ID and see, okay, what location does it represent, or what clothing does this developer have? They have white tank top. Okay, it's just a gimmick. It doesn't really represent anything real. These are NFTs of developers. It's more of a kind of experimental setup. So that's how you can interact with the contract right here. You can also write to it if you want. You can call the write functions. Like, for example, if you want to transfer your NFT, you can do it in here. You can write a program to do it as well, but it's a lot easier to just go here and do it. Now, the source of the contract should be available. So if we go look at the contract here, what you can do on Etherscan.io specifically is you can upload the source code and it'll verify it. It'll compile it itself, make sure that the bytecode matches. And then you can go here and you can actually just look at the source code. And you can see if it's had some audit submitted, I guess. But here's the whole program right here. And this is, I think, all mostly just taken from Open Zeppelin, but it's the same deal. So you can go read through the contract yourself. If you like it, you can work with it. If you don't like it, you don't have to interact with it.
So in theory, you can have like any number of public functions that do any sort of stuff that you want inside of the code, except for those that are needed because of the interface.
Yeah, I mean, it can be any sort of program you want to write. Yeah, it's just a program. And you can have programs call other programs as well. So you can make functions externally callable if you want. So you can see this one's internal. Others are not internal. Like this guy. And if you want any kind of metadata, if you want it to represent something that is encoded on the blockchain and saved, you can do that. You don't have to. You can have some other application somewhere else that just knows, what each NFT represents or what the tokens represent. It's up to you.
Nice.
Any other?
I mean, I could
Well-
honestly ask you like 1,000 questions about this, but I'll just ask one more because I don't want to spam too much. So I like you mentioned that it's sending events like a transfer event or things like that. So
Mhm.
those events are on the Ethereum network. They have some set of events that are supported basically.
Yeah, so you can see here, these are the events for this contract. Transfer approval. Semantically, I don't really know what the events mean. Like, I mean, it's obvious that, okay, this represents a transfer, but what does emitting the transfer do? I'm not sure. Is it part of the standard? I'm not sure. We can look. Yes. So transfer must trigger when tokens are transferred. Approval, blah, blah, blah. So exactly under the hood how the events are used, I'm not really sure, but they do exist. They are part of Ethereum. They are part of the interface.
Okay, thanks a lot.
Let's end the presentation for now. We can have more of a discussion together.